This basic course is designed to improve software developers' algorithm problem-solving ability through learning of basic data structures and offering various exercises and practice sessions to improve implementation capability. Accordingly, the learning targets of this course are software developers and persons who wish to strengthen software problem-solving ability. Through this course, you can understand the basic data structures and strengthen your software algorithm problem-solving ability. Welcome! Today, you'll understand and explain the concept of algorithm, the concept and necessity of array. You can declare and use one-dimensional array, and explain the concept of exhaustive search, greedy algorithm, and sort. Lastly, you can explain the alignment method of bubble sort and counting sort. Go check learning contents as well. Algorithm is a procedure or method of solving a problem in a finite stage. Often used as a computer term, it is a stepwise procedure for a computer to perform an operation. In other words, it is a procedure to solve a problem. Let's think of a question of doing the sum of 1 through 100. To find the sum of 1 through 100, you can simply add from 1 to 100. However, you can see that the sum of 1 and 100, 2 and 99, and 50 and 51 is all 101. Now you've found that 101 multiplied 50 times is the sum of 1 through 100. This type of problem-solving technique is called algorithm. You can use pseudocode and flowchart to express an algorithm in the field of computer. Pseudocode is a type of code that designs an algorithm by copying a code with a usual language, not written by the grammar of certain programming language. Pseudocode, to the literal sense of the word, only copies something, and therefore is not executable on computer as a code designed by actual programming language. It is mainly used for rough algorithm modeling before programming with certain language. This is a type of chart that expresses the processing flow of program or operation in various signs and characters according to the order. Also referred to as a flowchart, it is mainly used to express logical flow of program and data processing process. It's mandatory for understanding overall flow and process of program before programming. The purpose of this process lies in understanding and using a better algorithm. The standards for evaluation of algorithm include accuracy, workload, memory use amount, simplicity, and optimality. Accuracy is what shows how accurately an algorithm operates. The higher the accuracy, the better the performance. Workload is what shows how great outcome it gets with a few operations. The less the workload, better the performance. Memory use amount is what shows how little memory an algorithm uses. The less the memory use amount, the better the algorithm. Simplicity is what shows how simple an algorithm is. The simpler the algorithm, the better the performance. Optimality is what shows how optimal an algorithm is without any room for improvement. The less room for improvement, the more optimal the algorithm. A variety of algorithms are used to solve a problem. Solution of problem differs by the questions of which algorithm is employed. This is why we have to analyze the performance of each algorithm. Workload is, in many cases, used as a standard for performance analysis of algorithm. For example, let's think of a question of doing the sum of 1 through 100. Algorithm 1 simply adds from 1 to 100 and runs 99 times of operation. For example, 99 times of addition. Meanwhile, algorithm 2 multiplies the sum of the first and the last numbers to the total number of numbers, and then divides it by 2. In this case, it runs 3 times of operation in total, including 1 addition, 1 multiplication, and 1 division. Giving the number of operations only, algorithm 2 has even less number of operation than algorithm 1. You can also see that such difference gets bigger as the range of addition gets bigger than 1000 or more. In general, time complexity is used to express the workload of an algorithm. There are two ways of measuring workload. One is to measure and express the runtime of program in time, and the other is to view a command statement as a unit time and calculate the number of command statements in progress. The former may differ by the setting in which a program runs. The method of calculating the number of command statements is more widely used to measure time complexity. For example, algorithm 1 runs for n number of inputs, twice of operation after a command statement starts, and then enters a repetitive statement to run 3 times of operation n times. To formulate it for the value n, time complexity becomes 3n plus 2. As algorithm 2 has 4 command statements in total, time complexity becomes 4. One of the ways to express time complexity is Big O notation. Big O notation indicates only the term for n that has the biggest influence among all time complexity functions and skips coefficient. For example, Big O 3n plus 2 drops a constant, selects leading term 3n only, removes 3, the coefficient of n, and indicates as Big O n. Let's take another example. O 2n2 plus 10n plus 100 is noted as O n squared. When notated in a constant, it yields 1. For instance, O4 is notated as Big O 1. Removal of coefficient and constant, as well as indication of leading term among the inputs, is what affects algorithm most, designed for simple expression. Different time complexity algorithms present the following number of operations as the number of elements increases. In case of algorithm with time complexity whose number of elements is presented in a square number, exercise caution as the number of operation increases exponentially. The table here shows the actual runtime by time complexity. When assuming a machine that can make 100 million computations in 0.1 seconds, it can be seen that the algorithm with log n complexity takes 0.027 microseconds. You can also see that an algorithm with time complexity of n squared needs about 115 days. Suppose that two algorithms for the same problem has a different level of time complexity, such as log n and n squared. Which algorithm will you choose? Let's put it in another way. Suppose that a program designed for the inquiry on the population of South Korea needs less than 1 second to get an answer, whereas the other needs 500 days. Which program will you choose? Before we run a program, we can use the concept of time complexity to forecast and compare them. The purpose of learning time complexity lies in here. How was the class today? We'll sum up what we studied today.